with Oscar class. That's my dad.
Hi. What we're going to be looking at now are measures of center, which in the Holt Algebra 2 textbook is section 11-5. First, we're going to talk about the basics, the three M's that we know and love from previous courses: the mean, the median, and the mode. When we talk about a measure of center, what we're focusing on is a way of taking a collection of data and boiling it down to a single value that represents how that collection of data works out overall. So for example, if I were to talk about test scores, here's a list of 12 of them. I might use the measure of center as a way of evaluating how the group did overall. So the measure of center provides a single value I can use to say, well, this group generally got a blank on this assignment. So here's my collection. I have 4 100s, then a 94, a 92, an 86, an 84. Then we go down to a 78, 75, a 50, and then a 10 for my last student. So if I look at this, the top 6 out of my 12 are all in the A range. And the bottom 6 varies with 2 B's, 2 C's, and 2 E's. That would be a traditional grading scheme. When I talk about measure of center, then the question would be, how did my students do overall, and which is the best descriptor of the group? Let's start by talking about the mode. It's the one that we generally tend to reject for data sets because it's not very useful for really getting to the middle in truly spread out data. It also doesn't fit really well with our common application, for example, of school grades. The mode, remember, is the item that happens the most in a group. Given this data set, everything happens exactly once except for the score of 100. So if I were to talk about a measure of center for this, the mode for this data represents 100. So again, if I want to talk about how my students did overall, I can say, well, generally they did fairly well. I had a lot of 100s. And that is true. In fact, 4 out of 12, so roughly a third of students, got an A on this, a perfect score. That is not necessarily a bad measure then. The median, you'll hear that a lot when we talk statistics. One of the numbers we like to use is the median income for a region. The median is the value at the middle. Now, since we have an even number of data points, I'm going to have to take an average of the numbers on either side of the middle. I have 6 scores here and 6 scores here. So the middle score would be between the 92 and the 86. Okay, well there's nothing in that middle spot. So I'm going to take the average of 92 and 86. Now if I were to drop the 10 out of my data set, the middle value of the 11 remaining data points will be that 94. But that 10 is still in my data set. So I'm going to go ahead and I'm going to include that. Now I need to take the average of these two values. Find the point that's exactly halfway between them. That's a 6-unit difference. Half of 6 would be 3. And so therefore we're looking at a median of 89. As a general rule, we like the median more than the mean because the median is not nearly as impacted by values at the extremes. I'll explain that when we start calculating the mean out. Remember, the median represents the middle value. And if I have an even number of values, I take the average, in this case 89, which does not appear here, and I use that. So that 89 comes from, again, 92 plus 86 divided by 2. Now the mean is the classic average. Add up all of your data and divide it by the number of data points. In this case, if I add up all of these values, I get a total of 969 divided by 12 gives me an average of 80.75. That would be the mean for this collection of data. Now you'll notice it's substantially lower than the median. Part of that is owed to the fact that I had this 10 down here at the bottom. These 100s are all grouped together. I have a great number of students, a third of them, who got 100%. So it would make sense that I have a relatively high measure of center, because generally speaking, my students did fairly well. However, because of this 10 down here, that outlier tends to drag the average down. When we talk about median income, for example, if you have one or two families that are making in excess of $1 million in an area, that incredibly high income inflates the mean income for that area. Everyone else could be making $60,000, but that one or two family making $1 million pulls up the average. When we talk median, even if these numbers could be as high as I want, they could be $1 billion, the middle value is still between this 92 and the 86. So that one very far outlier is not as much of a factor. The same thing here with this 10 down here. This 10 could be as high as 49 or as low as 10. The median doesn't move. Now that said, what if we were to simply take and drop that 10 out of the picture? This is also something that happens a lot in statistics, and I'm doing it here to demonstrate the effect of outliers on an average. The average tends to be a student's typical first shot for a measure of center, and I'd like to show why it's not always your best bet. So again, let's take this data set. I'm going to knock out this 10, pretend it didn't happen. Now the median would slip up to 92, which is a small increase. The mode would not change, but without this 10 in my data set, I'm looking at 959 divided by 11. And that average is going to slide up to 87.18. Notice how much the average increases by dropping a single data point that's very far from all my others. Mean is a common value we use. We like to talk about the average of test scores, for example, but it's a very dangerous one to rely on exclusively because it's so easily impacted by extreme values in either direction. So to recap, mean, median, mode. Most often, the mode, the middle score, the median, and the average, the mean.